Something moved before time even existed. That idea should not be possible. It should not even make sense. And yet, modern physics is starting to point in that direction. For decades, science has told a clear story. The universe began with the Big Bang. In one single moment, space appeared, time began, energy flooded into existence. Everything that exists today traces back to that instant. Before that moment, there was nothing, no space, no time, no motion, no events, no cause. That is the standard picture, clean, simple, logical. But now cracks are starting to appear. Some of the deepest equations in physics no longer agree with that story. They suggest something far more unsettling, something that should not exist. They suggest that before the universe began, something was already changing, not just existing, not just sitting in silence, moving. This is where things start to break, because motion requires time. Change requires a sequence. One moment must come before another. That is how motion works. That is how reality works. But if time itself started at the Big Bang, then motion before that moment should be impossible. And yet, some of the most serious ideas in modern physics are pointing directly at it. This is not science fiction. This is not speculation from the edges. This comes from attempts to fix real problems in our understanding of the universe. Problems that scientists have not been able to solve for decades. At the center of this mystery is a simple but dangerous question. If something was already happening before the beginning, then was it truly the beginning at all? That question changes everything, because the Big Bang has always been treated as the starting point. The first page of the cosmic story, the moment where the clock began ticking, but if there was motion before it, then the Big Bang may not be the start. It may be just a transition. A phase change, one moment in a much larger process that we do not fully understand. And that idea is deeply unsettling. It means the universe might not have come from nothing. It means something existed before everything. And even more disturbing, it means that something might still be beyond our reach. Something that set everything in motion but cannot be observed, measured, or fully understood. This is where modern physics starts to feel uncomfortable. Because the deeper scientists look, the less stable the concept of a true beginning becomes. The equations that describe the earliest moments of the universe begin to fail. They produce infinities, they break down, they stop giving meaningful answers. This breakdown is not just a technical problem, it is a warning sign. It tells us that our current understanding is incomplete. And in that gap, new ideas have started to emerge. Some of them suggest that the universe did not come from nothing, but from a state that was already active. A state where change was already happening, even without time as we know it. Others suggest that time itself is not fundamental, that it is something that emerges later, like a shadow cast by deeper laws. If that is true, then motion could exist without time. Change could happen without a clock. Events could unfold in a way that does not fit our usual idea of before and after. This is where the idea becomes difficult to even think about, because the human mind depends on time. Every thought, every memory, every experience follows a sequence. One thing leads to another because it leads to effect. But at the deepest level of reality, that structure may not exist. There may be a layer of the universe where the rules are completely different, where the concept of before and after does not apply. And yet, within that strange framework, something may still be happening. Something may still be moving. That possibility has forced scientists to rethink one of the most basic assumptions in physics, that the universe had a clear beginning, because if motion existed before time, then the beginning is no longer simple and is no longer a single point. It becomes part of a larger, more complex story, a story that might stretch beyond our universe, a story that might not have a true starting point at all. And this is where things take a darker turn. Because if the universe did not begin in the way we thought, then the idea of a first cause becomes unstable. What triggered the Big Bang? If something was already in motion, then something must have set that motion in place. But then what set that into motion? This chain does not end. It keeps going. And that leads to a possibility that many scientists find deeply uncomfortable, that there may be no ultimate beginning, no first event, no clear origin. Only an endless sequence of states, changes, and transformations, a reality that has always existed in some form. That idea challenges more than physics. It challenges the way we think about existence itself, because humans search for beginnings. We look for origins. We try to trace everything back to a single point where it all started, but the universe may not follow that rule. It may not have a clean starting line. And if that is true, then the question shifts. It is no longer about how the universe began. it becomes something far more difficult. What is the true nature of reality if there was never a beginning at all? In this video, you will explore the hidden problems behind the Big Bang theory. You will see why the idea of nothing may not actually exist. You will learn how quantum physics allows motion to emerge from emptiness. You will discover theories that suggest time itself is not fundamental. And most importantly, you will face the unsettling possibility that something was already happening before the universe began. A possibility that changes everything we thought we knew. By the end, the concept of a beginning may no longer feel solid. It may feel like an illusion, a simplified story that hides a much deeper and stranger truth. If you are ready to question the origin of everything, then you are in the right place. Welcome to the channel. Subscribe now, because the deeper you go into this topic, the more reality begins to break apart. The Big Bang is often described as a massive explosion. That picture is simple, but it is wrong. There was no explosion in space. There was no empty stage where matter suddenly burst outward. Space itself was the thing expanding. Every point in the universe moved away from every other point at once. There was no center. There was no edge. The entire fabric of reality stretched in all directions. This detail changes everything, because if space itself began at that moment, then there was no place for anything to exist before it. No location, no distance, no direction. The concept of outside the universe stops making sense. Time is even stranger. In modern physics, time is not separate from space. It is woven into it. Space and time form a single structure called space-time. When the universe began, space-time itself came into existence. That means time did not flow before the Big Bang. It did not tick forward toward that moment. It started there. This leads to a very uncomfortable statement. There was no before. In standard physics, asking what happened before the Big Bang is like asking what is north of the North Pole. The question sounds valid, but it breaks the rules of the system. There is no answer because the concept itself does not apply. For a long time, this idea was accepted. It felt complete. The beginning of time marked the beginning of everything. End of story. But then the equation started to fail. When physicists try to trace the universe back to its exact starting point, the math begins to collapse. Densities rise toward infinity. Temperatures become infinite. Space shrinks to zero size. This point is called a singularity. It is not just extreme, it is undefined. The laws of physics cannot describe it. General relativity, which explains gravity and the large-scale structure of the universe, breaks down completely at that point. Quantum mechanics, which governs the smallest scales, also fails to give a clear answer. This is a rare situation in science. Two of the most successful theories ever created both stop working at the same place. That is a warning sign. It means the current model is incomplete. Something deeper is missing. The true nature of the beginning is hidden behind a wall that our equations cannot cross. And this is where things start to open up, because once the equations fail, the certainty disappears. The idea that the Big Bang is the absolute beginning becomes less solid. It becomes an assumption rather than a proven fact. In that gap, new possibilities begin to appear. Some physicists suggest that the singularity never truly existed. Instead, it may be a sign that a different kind of physics takes over at extreme conditions. A deeper layer of reality where space and time behave in ways that are completely unfamiliar. Others propose that the universe did not start from a single point at all, that the Big Bang was a transition from an earlier state, a phase where the rules were different but not non-existent. This is where the concept of before slowly returns, not in the eternal sense, but in a more subtle way, a way that hints at hidden structures beneath space-time itself. And if those structures exist, then the beginning may not be a true beginning. It may be a boundary, a limit of our current understanding, a surface hiding something far more complex underneath, something that was already there. In everyday thinking, nothing means empty. No matter, no energy, no activity, a perfect void. But in quantum physics, that idea collapses. What scientists call empty space is not empty at all. Even in the deepest vacuum ever created, something is still happening. Invisible fields fill every part of space. These fields never sit still. They vibrate, they shift, they fluctuate. This is known as the quantum vacuum, and it behaves in a way that feels almost impossible. Particles appear out of nowhere. They exist for a tiny fraction of a second. Then they vanish. These are called virtual particles. They are not directly observed like normal matter, but their effects are real. They leave measurable traces, they influence forces, They even push objects in controlled experiments. This means that nothing is active. There's constant motion, constant change. Events happening with no clear cause. This is not speculation. It has been tested. In one experiment, two metal plates are placed extremely close together in a vacuum. They should just sit still, but they move toward each other. The force pushing them together comes from these quantum fluctuations. It is called the Casimir effect. Even in total emptiness, the vacuum has energy. This changes the entire concept of nothing. Because if empty space is never truly empty, then the idea of a universe emerging from nothing becomes more complicated. It may not be nothing at all. It may be a restless background filled with hidden activity. Some physicists have taken this idea further. They suggest that the universe itself could have started as a quantum fluctuation, a sudden burst from this unstable vacuum, a random event that expanded and grew into everything that exists today. This sounds strange, but the math allows it. Quantum systems do not need a clear cause in the classical sense. Events can happen due to probability alone. A fluctuation can grow instead of disappearing. Under the right conditions, it can expand rapidly. This rapid expansion is similar to what is believed to have happened in the earliest moments of the universe during a phase called inflation. There is a deeper twist. The total energy of the universe might be zero. Positive energy from matter could be balanced by negative energy from gravity. If that is true, then the universe does not violate energy laws by appearing. It balances itself perfectly. So the idea forms a universe emerging from a quantum fluctuation. No classical cause, no external trigger, just the natural behavior of a restless vacuum. But there is a problem that refuses to go away. Fluctuations need a stage. They need a framework where these quantum fields exist, a structure where probabilities can play out, a system with rules, even if those rules are strange. So the question shifts again. Where did that framework come from? If the quantum vacuum gave rise to the universe, then what gave rise to the quantum vacuum? It cannot be nothing in the pure sense, because it has properties, it has energy, it follows laws, it allows change. That means something was already there, something deeper than space, deeper than time, a foundation that allows these fluctuations to exist in the first place. And that foundation may hold the real answer to what moved before the universe began. Time feels like the most basic part of reality. It moves forward, it orders events, it separates past from future. Every experience depends on it. But some physicists believe this picture is wrong. They argue that time is not fundamental. It is not built into the deepest layer of the universe. It is something that emerges later, like a pattern rising out of something more basic. This idea comes from attempts to combine gravity with quantum physics. When scientists try to describe the universe at its smallest and most extreme scales, time starts to disappear from the equations. One of the most famous equations in quantum gravity does not include time at all. It describes the entire universe as a single frozen object. No flow, no ticking clock. Just a complete structure that exists all at once. This is not a small detail. It is a radical shift. If time is not part of the foundation, then change does not unfold in the way people expect. There is no universal sequence where one moment leads to the next. Instead, reality may be made of different states that simply exist, and the sense of time passing could be an illusion that appears when these states are compared. This idea is difficult to accept because everything in human experience depends on time. Memory creates the past, perception creates the present, expectation creates the future. Without time, these categories collapse. But at the deepest level, nature may not care about that structure. Some researchers suggest that what we call time is a result of relationships between physical systems. When parts of the universe interact, they create a sense of order. That order feels like time moving forward. But it may only exist inside the system, not outside it. There is a lesser-known detail that makes this even stranger. In certain quantum experiments, the order of events can become unclear. Two events can exist in a state where neither clearly comes first. The sequence is not fixed. It depends on how the system is observed. This challenges one of the most basic ideas as in physics. Because an effect relies on order. A cause must come before an effect. But if order itself is not fixed, then causality becomes unstable. This opens a door that was once closed. If time is not fundamental, then the rule that nothing can happen before time begins may no longer apply. The phrase "before time" stopped being meaningless. It becomes a sign that time is not the right tool to describe what is happening. Motion could exist in a different form, not as movement through time, but as differences between states. A kind of change that does not require a ticking clock, a shift in the structure of reality itself. In that framework, something could happen without a first moment. There could be activity without a beginning. This is where the idea becomes deeply unsettling, because it removes the clear line that separates existence from non-existence. It removes the moment where everything starts. It replaces it with a deeper layer where the usual rules do not apply. And in that layer, something may have already been happening long before the universe formed in the way we recognize. Something that does not follow time, something that does not need a beginning. The idea of a single beginning feels natural. One moment where everything starts, one event that explains everything that follows, but some scientists believe that moment never existed. They suggest the universe may be part of a cycle.
Not a one-time event, but a repeating process. Expansion followed by contraction, birth followed by collapse.
Again and again. In this view, the Big Bang is not the first moment. It is a turning point. The universe expands for billions of years. Galaxies move apart.
Space stretches, but gravity still works in the background. In some models, that expansion slows down. It stops, then it reverses. Everything begins to fall back, galaxies move closer, temperatures rise, density increases, the universe shrinks into a hot, dense state. This phase is sometimes called the Big Crunch, but the story does not end there. Instead of collapsing into nothing, the universe may bounce. The extreme conditions could trigger a new expansion, a new Big Bang. A fresh cycle begins. This idea has been studied for decades, but it has evolved in surprising ways. Some modern versions do not require a full collapse. They suggest a bounce happens before a singularity forms. Quantum effects could prevent total collapse. Instead of reaching infinite density, the universe reaches a limit, then expands again. This avoids the breakdown seen in earlier models. There is a lesser-known detail that makes this even more unsettling. Information may survive the transition. In classical physics, a collapse would erase everything. But quantum theory suggests that information cannot be destroyed. If that rule holds, then traces of a previous universe could pass into the next one, not in a clear, visible way, but hidden in subtle patterns. Some scientists have searched for these patterns in the cosmic background radiation. This radiation is a faint glow left over from the early universe. It carries information from the first moments after the Big Bang. There have been claims of unusual signals, circular patterns, temperature anomalies, features that some researchers believe could be echoes from a previous cosmic cycle. These claims are debated. Many scientists remain skeptical, but the possibility remains open. If even a small amount of information carries over, then motion carries over as well. The collapse of a previous universe would not be a static event. It would be full of energy, movement, and change. That motion would feed into the next expansion. This means the Big Bang may not have started from stillness. It may have inherited momentum, the expansion of our universe could be the continuation of something that was already in motion. This shifts the entire perspective. Instead of a universe appearing from nothing, there is a chain of transformations, each cycle shaped by the one before it, each beginning linked to an earlier ending. And this chain may not have a first link. It could stretch back forever. An endless sequence of universes, each giving rise to the next. No starting point, no final state, just continuous change on a cosmic scale. In that framework, the idea of a true beginning fades away. The universe becomes part of a process that never stops. And whatever moved before a universe began may not belong to a different reality at all. It may be the remains of a universe that came before. There is another possibility that goes even further. The universe may not be alone. According to several modern theories, what we call the universe could be just one region inside a much larger structure. Multiverse, a vast collection of separate universes, each with its own space, its own laws, and its own history. In this picture, reality extends far beyond what can be observed. Our universe becomes a small part of something much bigger. One of the strongest ideas behind this comes from inflation theory. In the early moments after the Big Bang, space expanded at an extreme rate, faster than the speed of light. This expansion may not have stopped everywhere at once, Some regions could have continued expanding, creating new pockets of space. Each pocket becomes its own universe. These are often called bubble universes. Each bubble forms under slightly different conditions. That means the laws of physics inside each one could be different. Constants may vary, forces may behave in new ways. Entire realities could exist with rules that do not match ours. There is a lesser known consequence of this idea. These universes may not be completely isolated. In some models, bubbles can collide. When two expanding universes meet, the collision releases enormous energy. It can reshape the structure of both regions. Some physicists believe that such a collision could trigger the birth of a new universe. This introduces a new source of motion. Not from inside our universe, but from outside it. The energy that started our cosmic expansion may not have come from nothing. It may have been transferred from a larger system, a collision, an interaction, a disturbance in a higher level structure. There have been attempts to find evidence for this. Scientists have searched the cosmic background radiation for signs of past collisions. Strange cold spots, unusual alignments, features that do not fit standard predictions. One region, known as the cold spot, has attracted attention. It is a large area of space that appears slightly cooler than expected. Some researchers have suggested it could be the result of a collision with another universe. The evidence does not confirm many alternative explanations exist, but the idea remains on the table. If even one such signal is real, the implications are enormous. It would mean our universe has interacted with something beyond it, and that leads to a deeper realization. The cause of our universe may lie outside it. The motion that started everything may not belong to our reality at all. It may come from processes that operate on a level we cannot access. This creates a boundary that science may never cross, because any region outside our universe is by definition unobservable. Light from those regions cannot reach us. Signals cannot travel between separate universes in a direct way. That means the true cause could remain hidden forever. There is also a more unsettling detail. If universes are constantly forming in a multiverse, then our universe is not unique. It is one of many, possibly one of an infinite number, each with its own beginning, each with its own version of reality. That reduces the significance of our cosmic origin. The Big Bang becomes a local event, not a universal one, just one occurrence in a vast and ongoing process. And the motion that came before it may be part of a much larger system that continues to create new universes without end. For a long time, science aimed for a simple answer, a clear beginning, a single moment where everything started. That idea gave structure to the universe. It made reality feel understandable, but these new possibilities begin to break that structure. If motion existed before time, then the beginning is no longer clean. It is no longer a fixed point. It becomes unclear, blurred, almost unreachable. This is deeply unsettling for scientists because physics depends on clear rules. It depends on cause and effect. One event leads to another. A cause creates an outcome. This chain allows predictions. It allows understanding. But the idea of a true beginning already creates a problem. Every effect must have a cause. That is the rule. But the beginning of the universe has no earlier moment, no prior state, no cause within time. This creates a gap. Physicists have tried to solve this by suggesting the universe could be self-contained, a system that does not need an external cause. But the moment new ideas introduce motion before time, that solution begins to fail. Now the question returns with more force: what caused that motion? And then another question follows: what caused that cause? This chain has no clear end. It keeps extending backward. Each answer leads to a deeper question. Each explanation opens another layer. This is where the idea of an infinite reality appears. Not infinite reality appears. Not infinite in size, but infinite in origin. A chain with no first link, a sequence that never truly ends. This is difficult to accept because it removes the idea of a final explanation. There may be no ultimate answer, no single event that explains everything else. Some scientists find this possibility deeply uncomfortable. Others accept it as a natural outcome of the equations. There is another layer to this discomfort. Many of these ideas cannot be tested directly. A multiverse, if it exists, may be forever out of reach. The pre-Big Bang phase may leave no clear trace. A timeless foundation may not produce measurable signals in the way current experiments require. This creates a boundary. Science relies on observation, it relies on data, but these theories push beyond that boundary. They describe regions where evidence may never arrive. That does not make them meaningless, but it makes them harder to confirm, harder to reject. They exist in a space between physics and philosophy. There's also a lesser known issue. The more scientists refine their models, the more complex the universe becomes. Simpler explanations give way to deeper layers. Each layer introduces new variables, new uncertainties, new unknowns. Instead of moving closer to a final answer, the picture becomes more unstable. The Big Bang was once seen as the solid starting point. Now it looks more like a surface. A boundary between what is known and what lies beyond. And beyond that boundary, the rules begin to change. Time may not exist, because may not work in a simple way. Motion may not require a timeline. These ideas force a shift in thinking. The universe is no longer a simple story with a beginning, middle, and future. It becomes a system that may be cyclic, layered, or even timeless at its core, and the deeper the investigation goes, the more it challenges the assumption that reality can be fully understood at all. Because if the foundation of existence does not follow the rules that humans rely on, then the search for a complete explanation may never truly end. It may only lead further into questions that have no final answer. Something moved before the universe began. That single idea changes everything. The Big Bang no longer stands as the absolute starting point and begins to look like a transition, a boundary, a moment where something deeper passed into a form we can finally observe. The more closely science examines the origin of reality, the less solid that origin becomes. Time may not be fundamental. Space may not be the full picture. The universe may not be alone. Each layer reveals something more complex, something harder to define. Instead of a clean beginning, there may be a chain of events that stretches beyond what we can see, or a cycle that never truly starts or ends, or a deeper structure where motion exists without time and change does not follow the rules we understand. This leads to a final and unsettling realization. The universe may not have a beginning at all, not in the way the human mind expects, not as a first moment, not as a clear origin point. And if that is true, then the question of what started everything may not have an answer, or the answer may exist in a form that can never be fully understood. That does not make the search meaningless, it makes it more profound, because every discovery pushes the boundary further. Every answer opens a deeper question, and every step closer to the truth reveals how much remains unknown. The origin of the universe is no longer just a scientific problem, it is a doorway into something far more mysterious. If this idea stayed with you, take a moment to support the channel. Like the video, subscribe for more explorations like this, because the deeper the questions go, the more reality begins to shift.